Hello, my name is Kevin, and in this video I'll be going over my Labview program that allows for automation of the DLP 4500 of G-code. So first we need to make sure the Arduino is connected to DLP. So as you can see in the image, we have the Arduino with Arduino wires, and then the other half is the Molex wires. And the Molex connector is connected to J17, which is I believe I2C0, the master I2C port on the DLP. You can look for the full diagram on the DLP website, which I will link below in the video. And for the Arduino, um, there's two. Typically, it's either your board has two dedicated slots for I2C, the SDA and SCL slots, or you can use the A4 and A5 pin if you don't have those slots. And we want to make sure we are wiring the voltage to 3.3 volts instead of 5 volts. Okay, so to get started, we first need to open the Labview file. It should be the project file because there are DLLs that we need to load up. So here I clicked open the project file instead of the VIs, and it's gonna load up here. Now we select experimental 2, and we just say load was selected, and we will just wait for the DLLs to load and all of that. Alright, so after this loads, we need to figure out which COM port the Arduino is plugged into. So I'll open up Device Manager. You can search in the window toolbar, and then we go onto COM port, or the port section of Device Manager, and we can see USB serial device is COM port 18. So now I will change the serial port to COM port 18. If you don't see it, just press refresh. Yep. And now we're gonna flash the firmware that allows Arduino to communicate with Labview. Select the correct Arduino. Use the same COM port you found. After this finishes, just run the program and you're good to go. And now I'll go into how to use this with your G-code. So if you look here, I'm gonna scroll to the section of the code which has like the controls. So I'm just going to pause here and talk about a few things. So this section of the code is the section that sends the command to the DLP. And if you look in the center, we have a get global variable block. That's the input of 4. So basically what this means is this block, or this while loop, will constantly, every loop, it'll constantly look for the global variable 4. Think of 4 not as like a value, just as a variable. It could be like name, or just think of it just as a variable that stores value. And we're constantly accessing what value it is. And this is how we can automate with G code, because with the Aerotech CNC program, I can set global variables on the G code, which this Labview can access the values, and then the output, based on what value is, I can send certain commands to the DLP, which is how we automate things. If this doesn't make sense, I'll go more in depth in the video, so just bear with me. What you're seeing here is a case structure. So how case structures work is typically it's true or false, but you can modify it to receive to run based off of like a numeric input, which is what I did here. So think of this like a if statement in Python. Oh, basically I wrote a condition where it's if the global variable 4 is equal to whatever number, like 112, then it will run the whatever code is inside the 112 box. And the right here in the 112 segment, we have a code 100 or more of like array that's 144 and 7, and that array corresponds to the command which tells the DLP to allow manual input of LED power and set the intensity to max. So I'm going to quickly go over why the code 144.7 allows us to set the LED to manual input mode. So by default, the DLP is on automatic for intensity of the LED, which means you can't control how intense it is. You have to set it to manual, which allows you to manually control how intense the LEDs are. And on the left, you see a page from the DLP programmer's guide, and this section tells us how to do that. So if you look at the I2C section, that's like the subaddress. So the subaddress says 0x10, so we need to use the 0x10 subaddress to access this function. And if you look at the table, bit 0, bit 1, bit 2 corresponds to red LED enable, green LED enable, blue LED enable, and we want to have the binary 1 for all three of them. And um, so yeah, on the right you can see to so we have the 0x10, which is the hexadecimal of the sub address we're trying to use. And then on the top we have 0x80, which is the right bit. We combine it, basically just add a 1 to the right bit, which is the like the 7th bit or the 8th bit, and we get 0x90, which is 144. So it's basically access the LED enable output function and allow me to send data to it, which is what the right bit tells us to do, or allows us to do. And on the bottom, you see that the hexadecimal 0x07, bit 0, bit 1, bit 2 on the right is equal to 1, which corresponds to the values we want on the, if you look at the table, we want one one for red LED enable, one for green LED enable, and one for blue LED enable. Therefore, when we send the decimal, or when we send the array, which is 144 and 7, it's going to tell the DLP that we want to have manual access to change the intensity for red, green, and blue LED. And every every function that I automate follows the same principle. I just use the DLP program's manual, do some like um, binary operations to figure out the stuff and send the data. So this is the expanded view of this case structure. I have like different commands from ranging from 100 to 112, and 1 is the default case, which means if global variable 4 is not equal or if global variable 4 is equal to anything other than 100 to 112, run the default case, which I've set to 1. So basically, if global variable is equal to 4, 5, 6, 7, 8, 9, 10, 1,000, anything that's not from 100 to 112, it'll run that. You can think of this as like a else in the if statement. So in the if else statement on Python, you have like if conditions, and then else is just anything that's not part of the if condition. Like if nothing matches any of the previous conditions, run else, which is why I have. So for one, I have it set to load image. So basically what the load image command does is it will load the image based on the index you provide. So if you set global variable for equal to 1, it will load the image from the first index, basically project the image of the first index. If you do global for is equal to 10, it will load the 10th index image. So that's how this works. And right here, I'm just going to just like help visualize. So yeah, I'm just gonna jot down some of the global variables I mentioned before and like write notes. Yeah, make sure you use. I think I said this before. Make sure you use like a delay between if you're doing consecutive global variables, because if you run it without delay, it'll send two commands at the same time and it won't run anything. So add like a 0.25 millisecond delay or 250 millisecond delay. And to do that, you just use the code G4P4 or P2.250, which says do a 250 millisecond delay. So yeah, make sure you run the Labview before running your G code, and it should work. You should be able to control the DLP with the global variables. Yeah, and make sure you flash the firmware before doing so. Like what I showed earlier in the video with the Maker Hub stuff, make sure you find the right COM port and just run the Labview and then run your G code, and everything should work fine.